we now discuss the solutions of the 3 questions that have appeared in the joint entrance examination main held on 27th June 2022 in the first shift. The first question is on the concepts of functions. The second question is from the subsection complex numbers. The third question is on the sum of the roots of a given cubic equation. We will now first discuss about the first question. The first question is on functions. The given question is, let f be a function from the set of real numbers into itself defined by f of x is equal to 2 times e power 2x by e power 2x plus e. Then f of 1 by 100 plus f of 2 by 100 plus f of 3 by 100 plus etc. plus f of 99 by 100 is equal to. We are given a function from the set of real numbers into itself defined as f of x is equal to 2 times e to the power of 2x by e to the power of 2x plus e. Then we have to find out f of 1 by 100 plus f of 2 by 100 plus f of 3 by 100 plus so on and so forth plus f of 99 by 100. We have to find the value of this sum. That's our given question. We will now discuss the solution of the problem in detail. We have f, a function from R into R defined by f of x is equal to 2 times e power 2x by e power 2x plus e. We have to find the value of this sum, f of 1 by 100 plus f of 2 by 100 plus so on and so forth plus f of 49 by 100 plus f of 50 by 100 plus f of 51 by 100 plus so on and so forth plus f of 98 by 100 plus the last one f of 99 by 100. Observe that the first one and the last one can be, we are grouping the first one and the last one as the first group. Now the second one and the last but one we are grouping, and I have shown that with the same color, and f49 by 100 we will group with f51 by 100, and we will be left with only one term, that is f of 50 by 100. So we are grouping into 49 groups and we are left out one term, that is f of 50 by 100. And now the first group is this one, first and the first plus the last, second plus last but one, plus so on and so forth. The 49th one, f of 49 by 100 plus f of 51 by 100. This is the 49th bracket. This is the second bracket. This is the first bracket. And you are left with f of 50 by 100. So we have written grouped. We have taken two elements and grouped it as one group. Right. We got 49 groups and one term is left out. Now, this f of 99 by 100, you can see it as f of 1 minus 1 by 100. And this f of 98 by 100, you can see it as f of 1 minus 2 by 100, and so on and so forth. So you will get f of 1 by 100 plus f of 1 minus 1 by 100. The second one, f of 2 by 100 plus f of 1 minus 2 by 100. And the 49th bracket is f of 49 by 100 plus f of 1 minus 49 by 100 plus f of 1 by 2, because 50 by 100 is 1 by 2. So this is f of x plus f of 1 minus x. for x is equal to 1 by 100, for x is equal to 2 by 100, for x is equal to 49 by 100. So we will now compute what is the value of f of x plus f of 1 minus x. Agreed. F of x is, we have written 2e to the power of 2x by e to the power of 2x plus e, and f of 1 minus x, and in this wherever there is x you write 1 minus x. Yes. Now the first term write it as it is, and in the case of the second term multiply both numerator and denominator by e to the power of 2x. When you multiply by e to the power of 2x, the numerator will be 2 into e square, and when you multiply the denominator by e to the power of 2x, it will be e square plus e into e power 2x. Agreed. And now in the second term, in this term, what you see is 1e is common. 1e is common. So cancel the e, then you will get 2e by e plus e power 2x, and you notice the denominator is same. The denominator is same. Now add, you will get 2 times of e power 2x plus e by e power 2x plus e, and the numerator and denominator, the same term is there, that is namely e to the power of 2x plus e. Cancel that and you will get 2. So that means f of x plus f of 1 minus x for all x belongs to R, the value is 2. So therefore the first bracket will be 2, the second bracket will be 2, the 49th bracket will be 2. So leaving the last one, you will get 2 plus 2 plus 2, 49 times you get, and this f of 1 by 2 we have to see. So f of 1 by 2 is equal to, and f of x you write down, and wherever there is x you just write 1 by 2. So 2x will be 1. So 2e by e, say 2e by e plus e. 2x is 1. See, x is 1 by 2, 2x is 1. 2e by e plus e, that is 2e by 2, 2e by 2e, that is 1. So this is 1. So now the answer is very clear. Now 2 into 49, that is 98, and this is 1, that is what? That is 98 plus 1, that is 99. So that we will see in the next slide. So that's what we have done so far. F of x plus f of 1 minus x is 2, f of 1 by 2 is 1. So now this will be equal to 2 plus 2 plus 2, 49 times, plus f of half is 1. That is equal to 49 into 2 plus 1. That is equal to 98 plus 1. That is equal to 99. So that is the answer to this question. That is the detailed discussion of the solution of the problem of the first question, which is based on the concepts of functions. Now we move on to the second question. The second question is from the subsection complex numbers, and the question is on complex numbers. And the area, the given question is the area of the polygon whose vertices are the non-real roots of the equation z bar is equal to I times z square is. We are given 4 options. Option A, 3 root 3 by 4. Option B, 3 root 3 by 2. Option C, 3 by 2. Option D, 3 by 4. So we are given a complex equation, z bar is equal to I z square, and it is given the non-real roots of this equation are the vertices of a polygon. If that is so, what is the area of that polygon? That's our given question. So z bar is equal to I times z square, where z is a complex number. Agreed. For z, we write down x plus iy, then z bar, the complex conjugate of z, that is the complex conjugate of x plus iy, is x minus iy. So that will be x minus iy is equal to I times x z square, that is x plus iy whole square. When you square x plus iy whole square, it is x square plus I square y square. I square is minus 1, therefore x square minus y square plus 2ixy. So x minus iy is equal to I times x square minus y square plus 2ixy. Now I multiplied by 2ixy will be minus 2xy, that's the real part. The imaginary part is I times of x square minus y square. So now two complex numbers are equal if and only if the real part is equal to the real part, imaginary part is equal to the imaginary part. So equating the real and imaginary parts on both sides, we get x is equal to minus 2xy, yes, and minus y is equal to x square minus y square. Agreed. This will imply, so bringing minus 2xy to the left hand side, then you will get x times of 2y plus 1 is equal to 0, that is the first one. And bringing this minus y square to the left hand side, we will get y square minus y is equal to x square. So we deal with two cases. First case, so first one is x into 2y plus 1. X into 2y plus 1 is equal to 0 will imply either x is equal to 0 or y is equal to minus 1 by 2. We deal with two cases. First case, when x is 0, go to the second equation, that is y square minus y is equal to x square. So y square minus y is equal to x square. When x is 0, it is 0. Y square minus y is 0 means y into y minus 1 is equal to 0, means y is equal to 0 or y is equal to 1. So what is the solutions? X is 0, y is 0, that is z is equal to 0. X is 0, y is 1, then z is equal to x plus iy will be I. So you will get z is equal to 0 plus I 0, 0, and z is equal to 0 plus I times 1, that is equal to I. Agreed. Take the second case. So second, y is equal to minus 1 by 2. So take the next equation, that is x square is equal to y square minus y, yes, yes, and y is equal to minus 1 by 2, substitute, and that will be equal to x square is equal to minus 1 by 2 whole square minus minus 1 by 2, that is 3 by 4. Therefore x is equal to plus or minus under the square root of 3 by 2. So what are the complex number? So x plus iy, that is plus or minus root 3 by 2 plus I times minus 1 by 2. So plus or minus root 3 by 2 minus 1 by 2 I. So there, what are the non-real roots? Now first take, how many roots have we got? 4 roots we got. What are they? 0, I, and these are the two ones. Agreed. The first one, 0, is a real number. So the remaining are all non-real roots. Therefore, the non-real roots of the equation z bar is equal to iz square are I root 3 by 2 minus I by 2 minus root 3 by 2 minus I by 2. So we got the non-real roots of the equation z bar is equal to iz square. These are the three roots. We continue in the next slide. And we are given the non-real roots of this equation are the vertices of the polygon. So the vertices of the polygon are these non-real roots, these three roots. And these are distinct points. So therefore, this polygon is nothing but a triangle. So note that it is a triangle with vertices at right in a Cartesian form. I means A 0, 1 and B root 3 by 2 comma minus 1 by 2, right? C the ordered pair minus root 3 by 2 comma minus 1 by 2. So it is so now let's look at plot this. Let's look at so that's x-axis, y-axis, right? That is the origin. Okay, so A is yeah, right? P, yes, in the third quadrant. and C in the fourth quadrant. Agreed. Now this is it forms a triangle. It forms a triangle, right? And we observe that it is an isosceles triangle with the base BC. With the base BC is the distance between root 3 by 2 to minus root 3 by 2. That is the difference only, the difference. That is mod of minus root 3 by 2 minus root 3 by 2. That is 2 times root 3 by 2. That is root 3. So base B is equal to BC. That is 2 into root 3 by 2. That is root 3. And the height H, the height H is equal to AO, that is 1 unit. And OM, only length you have to take. The length is 1 by 2, because height is the length. 1 plus 1 by 2, that is 3 by 2. So AM is 3 by 2. So the area of the triangle is 1 by 2 into base into height, that is equal to 1 by 2 into root 3 into 3 by 2. That is 3 root 3 by 4. So that is the answer to this question. And our answer 3 root 3 by 4 appears against option A. The answer to this question is option A. That is the detailed discussion of the solution of the problem, which is based on the concepts of complex numbers. We now move to the third question. The third question is the sum of the roots of a cubic equation. The given question is, if the sum of all the roots of the equation e power 2x minus 11 e power x minus 45 e power minus x plus 81 by 2 is equal to 0 is log of p to the base e, then p is equal to, we are given an equation, this is the equation, and the sum of all the roots of this equation is given to be log p to the base e. Then we have to find out what is p. We now discuss the solution of the problem in detail. The given exponential equation is this one. And that equation, you take it, call it as 1. This is equivalent to same as. So e to the power of minus x, we have written 1 by e power x and taken the LCM. And that will be 2 e to the power of 3x minus 22 e power 2x minus 90 plus 81 e power x. Now adjusting the terms, it is the same as 2 e to the power of 3x minus 22 e to the power of 2x plus 81 e power x minus 90 is equal to 0. It is same as 2t cube minus 22t square plus 81t minus 90 is equal to 0. Let's call this as equation 2, where t is e power x. So these are equivalent. That means the transition of the roots, how it will travel from 1 to 2 and vice versa from 2 to 1. I will tell you. If x1 is a root of the given equation 1, then t1 is a root of the equation 2, where t1 is e power x1. So if you know a root of 1, then a root of the second equation is simply e power x1. Conversely, if t1 is a root of the equation 2, then t1 will be e to the power of some x1. So that means x1 will be log t1 to the base e. So if you know t1 is a root of the equation 2, how do you get a root of 1? That will be x1 is equal to log t1 to the base e. So you take t1 is a root of second, take the logarithm to the base e, then that will be the root of the equation 1. So that is the transition of roots from equation 1 to 2 and conversely from equation 2 to 1. We continue in the next slide. Agreed. That's what we have done. Now, let us take the second equation. Second equation, because we want to talk about the sum of the roots of the first equation is equal to something is given in the question. So let's start from 2 and travel to 1. Agreed. So let T1, T2, T3 be the roots of the equation 2. Because it is the equation 2 is a cubic equation. A cubic equation. By fundamental theorem of algebra, it will admit 3 roots. Therefore, T1, T2 and T3 be the roots of the equation 2. So if you know T1, T2, T3 are the roots of the equation, then logarithm of T1 to the base E, logarithm of T2 to the base E, logarithm of T3 to the base E are the roots of 1. Let's call them as x1, x2, x3. So xi is equal to log of ti to the base e, where I is equal to 1, 2, 3 are the roots of the equation 1. So let's take T1, T2, T3 itself, and we will write the product of the roots. Now T1, T2, T3, the product of the roots of the second equation. Let's recall our past knowledge. And if you are given a cubic equation, ax cubed plus bx square plus cx plus d is equal to 0, and if alpha, beta, gamma are the roots of this cubic equation, then the first one, the sum of the roots, that is alpha plus beta plus gamma is equal to minus the coefficient of x squared by the leading coefficient, that is the coefficient of x cubed, that is minus b by a. And second one, the sum of the roots, the product of the roots taken 2 at a time. Product of the roots taken 2 at a time. Alpha beta plus beta gamma plus gamma alpha is equal to the coefficient of x by the leading coefficient, that is c by a. And the 3, that is the product of all the 3 roots, is equal to minus the constant term by the leading coefficient, that is minus d by a. Here we want T1, T2, T3, the product of the roots, and that will be equal to the minus the constant term, that is minus 90 by the leading coefficient is 2, that is plus 45. Now take the logarithms on both sides. So that is log of T1, T2, T3 to the base e is equal to log of 45 to the base e. And log of the product is equal to sum of the logarithms. And that will imply log of T1 to the base e plus log of T2 to the base e plus log of T3 to the base e is equal to log of 45 to the base e. Agreed. And now what is log of T1 to the base e? x1 plus x2 plus x3 is equal to log of 45 to the base e. What are these x1, x2, x3? The sum of all the roots of the equation 1. So equation 1, sum of all the roots of the equation 1. And that is given to be log 45 to the base e. But it is given the sum of all the roots of the equation 1 as log p to the base e. This and this are one and the same. Therefore, log p to the base e is equal to log 45 to the base e. Comparing, we will get p is equal to 45. That's what is wanted. That is what is wanted in this question. So that is the p is equal to 45 is our answer. That is the detailed discussion of the solution of the problem on the sum of the roots of a given cubic equation. I am sure that you have understood the solutions of the 3 questions what I have explained here, and I wish you all the best. Thank you.